So we left off. Here, okay? So the last thing we're going to do with these parametric equations is if you are given an equation, and in these situations you're going to be given one equation, you're going to get two equations, one that has a t in it and one that doesn't. And you have to introduce the t into the second equation. So you're going to take the one that does have the t, solve for the variable that's not t, there will be two variables, and then take it and substitute it into that second equation. And your solution is going to be two equations, one x equals and one y equals, and they both have to have a t. So your answers here are going to be an x equals and a y equals, and somewhere in these equations they both have to have a t. So you're working in the reverse. I'm going to give you a rectangular equation and a parametric, and you have to result into parametric equations. So these questions, in my opinion, the instructions are a little bit confusing. I modeled this right after WebAssign, which is right after your book. This is two different questions. So people tend to think that A and B are related. They are not. So this is two completely different questions. Okay, A goes with the instructions and B goes with the instructions. So it says find a set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters. The first parameter is that t equals x. So the first thing I'm going to do is just rewrite the equation that's in the directions down here so that we know we are only focusing on these two. So I've got two equations, one that has a t and one doesn't. The one that doesn't, I have to put the t in, okay? So look at the equation that does have the t. If it wasn't already solved for the other variable, I would, but it already is. All I have to do is take the value that x equals, which is t, and plug it right into the other equation. And I end up with y equals 1 minus t squared. If I needed to simplify it, I would. I don't need to simplify that one, okay? And then the answer is not only that equation, but also the first one as an x equals. So I'm going to rearrange it so that it's x equals t. And then my answer would be y equals 1 minus t squared and x equals t. Again, you're creating that system of parametric equations. Yeah.
So if it gives us one that just like t equals y or t equals x, we just flip it?
You just got to plug it in. Yeah. It's probably not going to be that easy, but yes, that's a general concept. Yeah. Okay, so then B is a completely separate question. Same set of instructions. Find the set of parametric equations to represent the graph of y equals 1 minus x squared using the parameters. And here's the y equals 1 minus x squared now goes with t equals 1 minus x. So I want to plug in place of the x, which means I'm going to take this first equation and I'm going to solve it for x. So I would get t minus 1 equals negative x. Divide or multiply by negative 1, I get negative t plus 1 equals x. So you want to solve the one that doesn't have the t for the other variable, and then take that expression and plug it in the place of what it equals. So then I get y equals 1 minus negative t plus 1 squared. 1 minus, this would be negative t plus 1 times negative t plus 1. Or you can use your shortcut to multiply that out now that we've practiced our shortcut more with our rotation of the conics. The shortcut is square the first term, which would be t squared. Square the last term, which would be 1. And then double the product here. So 1 times negative t is negative t times 2, negative 2t. Then distribute your negative. 1 minus t squared plus 2t minus 1. The 1 and the negative 1 cancel out, and I get y equals negative t squared plus 2t. So my answer is both the original one that they gave me with the t. I already solved it for x, so that's how I'm going to write it. X equals negative t plus 1, or 1 minus t. The order doesn't matter there. And y equals negative t squared plus 2t. Yep.
So once again, you just flip the x, right?
Yeah, you're just solving for, it may not always be x that has the t. Whichever one has the t, you're solving for that variable, and then you're plugging it in the place of the other one. So the idea is, this is like the reverse of what we just did. What we just did was get rid of the t, and we got a rectangular equation, something like y equals 1 minus x squared. We graphed it, right? And that's your approximation. So now it's saying, if you had the approximation one, how would you work backwards to get the two initial equations? So if I took this box and I did what we do in the beginning, get a t-chart, plug in the t, find the x, the y, and then make my graph, it should look like my 1 minus x squared. Yeah.
No, I was going to ask if the order of the equations mattered. But
Nope. Yeah. So most likely this kind of question is either going to be multiple choice where it wouldn't matter, or on your answer sheet. I haven't made your quiz yet, but let's say I do. On the answer sheet, it would say maybe x equals and then y equals, so that it's easier for me to grade, and you'll know just to plug those in that order. That's it. Yep. Sure. Questions on anything 9-4 related? So this is like question 4 and 5. 1, 2, and 3 are the ones where you're going to graph using your t-chart and then eliminate your parameter. So tomorrow I lose the juniors first class period. We are going to start polar. So my advice, and I will remind you again in the morning, is to make sure that you just watch that video so you can understand a little bit of what we're doing, because you'll be really confused on Friday if not. But I'm going to do the same thing with tomorrow's homework, is stretch it over the course of the 2 days so that it's not due until Monday, so that otherwise not fair for the juniors. Class ends 9:20. Okay, so I'm going to let you work for a little bit, and then I'm going to call you back in because I'll go over the chapter 8 test that I gave you guys. I think I gave back to you last week, and I told you make sure you bring it back because I want to go over it. That's what I want to go over today because we've got a little bit of time.